Hello, this is Akshay with another video here, and this video is going to take on the numerical problem. And remember, numerical problems are always gonna be based upon the concepts you have already learnt. So this very numerical problem is also going to test the conceptual clarity you have got up till now. So let us just go through the statement just to take a stock of things lying inside this very numerical problem. So there you are right now. If in a given circuit diagram, this is a circuit diagram. Okay, R1 is 10 ohm, R1 is equal to 10 ohm, R2 is equal to 40 ohm. Here it is, R3 is equal to 30 ohm, R4 it is equal to 20 ohm, R5 is equal to 60 ohm, and a 12-volt battery. There it is, a 12-volt battery is connected to the arrangement. So this is the arrangement having 12-volt battery. Yes, question is here, calculate the total resistance. What's the resistance in totality of this very circuit? Total resistance. And the third one is the total current. So first things first, we are going to find out the total resistance. As I have told you in my previous video, as far as the numericals are concerned, that is, firstly, try to understand or try to find out what the nature of the combination these resistors are in a given circuit diagram. Once we know the nature of the combination, it's very easy to just go ahead. Without knowing the nature, we can't move an inch further. So let us take a look look at this very combination. Remember, R1 and R2, both the resistors are in parallel combination, and how it is, that is, yes, here it is, a connecting wire is coming from one end of the R1 being over here, and another one end of the R2 is being connected over here, and this is one common point created for these two resistors, and the another end of this R2 resistor is being over here, and the another end of R1 resistor has been put over here. So this is the another common point, and by definition these two resistors are in parallel combination. A, B, over here R3, R4, R5 are also in parallel combination. Why? Because here it goes, one end of R3 resistor is being put up here, one end of R4 is being put up here, and the one end of R5 resistor is being put up here. So one common point created for one end of these three resistors over here, and the remaining end, other end of R3 is being connected over here, one end of R4 resistor is being connected over here, and the other end of R5 resistor is being put up here. So there is another common point being created. So by definition, these three resistors are going to be in parallel. In order to just crack such kind of a numerical problem, the main mantra is just to simplify as far as possible. Simplify this very circuit diagram. Just apply what kind of the combination both are in. So apply those rules and regulation, and thereby making this circuit diagram a simple kind of circuit diagram. And how can we do it? Just see here. These two resistors are in parallel. We will create one resistor out of them. One resistor. How? By finding out the resultant resistance of these two resistors by means of applying law of combination of resistances in parallel. Okay, we create one resistor. Thereafter, these three resistors are going to be transformed into one resistor, the same way we have just done over here. Since these three are in parallel, we will apply the law of combination of resistances in parallel to these three resistors in order to create one resistor out of them. So in final analysis, we are having only two resistors. Once we go two resistors, it becomes far more easier to just take a look at the kind of combination they are gonna be. Right now, both are in parallel, and these three resistors are in parallel to one another. But if someone asks you, that is, how do they are combined together? So remember, these two resistors are combined in series to these three resistors which are in parallel combination. So by now, it seems to be a bit difficult to digest what I am saying. But if I am gonna simplify this very circuit diagram for you, then it would be you to answer this very question, that yes, what kind of a combination they are gonna be. You will directly latch on to the answer by saying that is, oh, it's a series combination. So it's the mantra is simplification. So if you are encountering such kind of numerical problems which are kind of a complex, having a complex nature or having a mixed kind of a combination, the first is that is, yes, you must simplify as long as possible. Once you do that, you are in a driver's seat to find out but the combination finally they are in. So we are gonna firstly simplify it and then we are gonna make a final decision. So here it is. Here, so first of all, we will say here that is, since R1, R2, whatever it is given, we are gonna write over here. Here, yes, let us write it. R1 is equal to 10 ohm. R2 is equal to 40 ohm. R3 is equal to 30 ohm, R4 is equal to 20 ohm, and R5 is equal to 60 ohm. So this is what we have got. Remember, we are going to find out firstly the total resistance. In order to find out total resistance, firstly we are going to solve these two, R1, R2. Here says resistors R1 and R2 are in parallel combination. So we are going to find out the resultant resistance for these two resistors, and let equivalent or resultant resistance for the combination is equal to R. We have taken up to 5 and it's gonna be R6. So we are going to apply the law of combination of resistances in parallel, which states that the reciprocal of the resultant resistance is always equal to the sum of reciprocals of individual resistances. So the reciprocal of resultant resistance, this is the resultant resistance R6. So therefore 1 upon R6, that is the reciprocal of resultant resistance, is equal to the sum of reciprocals of individual resistances. These are the individual resistances. We are going to create the reciprocals and then add them together. 1 upon R1 plus 1 upon R2. That is the law of combination of resistances in parallel. Now we are going to put up the value here. 1 upon R6 is equal to 1 upon R1. How much it is? 10 ohm plus 1 upon R2, it is 40 ohm. Now it is a simple mathematics to get R6 here, or 1 upon R6, LCM is gonna be 40 ohm. Yes, 40 ohm. Now solve it. We are gonna get ohm cancel, 10 for the 40 and it is 4 plus 1 and it is 1, or 1 upon R6 is equal to 5 upon 40 ohm. Now we are going to find out R6. Make it a habit. You are going to apply the same operation on the both sides. And what's the operation is? That is, bring the denominator over here upside down. And here R6 goes up, 1 comes down. 40 ohm goes up, 5 comes down. Means denominator being transformed to numerator, or numerator has brought down to denominator. Same is over here. So what's going to happen? R6 is equal to 40 ohm upon 5. 40 ohm goes up and 5 comes down. Same is here, same is there. So it is equal to, and 8 ohm. So therefore R6 is equal to 8 ohm. So this is, let me tell you here, here it is. We have got one resistor out of these two, And let me just simplify it by doing this. It has gone away. Yes, it goes away. Now there is a simplicity you can see in this very circuit diagram. Earlier we have got two resistors over here, and now we have created one resistor. R6 is equal to 8 ohm. Same operation is going to apply over these three resistors to get one resistor. Same is here. Now we are going to just see here. Yes, this is the first part. Now the second part is that since these three resistors here, since R3, R4 and R5 are in parallel combination. So these three resistors are in parallel combination. Once again the story will be repeated. We are going to create one resistor out of these three resistors by considering that equivalent resistance of the combination. Let's say equivalent resistance is equal to, earlier we have taken R6 and let it be R7. So since this combination is in parallel, so we are going to apply the law of combination of resistances in parallel, reciprocal of the resultant resistance. Therefore 1 upon R7 is equal to the sum of reciprocals of individual resistances. Individual resistances are R3 and its reciprocal is 1 upon R3 plus 1 upon R4 plus 1 upon R5 or 1 upon R7. Just put the values of each and every resistance here. That is 1 upon R3 is 30 ohm. Yes, 30 ohm plus 1 upon R4 is 20 ohm plus 1 upon R5 is 60 ohm or 1 upon R7 is LCM is 60 ohm. 60 ohm is the LCM. Here it is. Now ohm cancel and 60 divided by 30 gives you 2, and here we have got 2 plus ohm cancel 60 divided by 20 will give you 3, and it is 3 plus 60 ohm divided, and finally you get 1 or 1 upon R7 is equal to 32516 upon 60. Same operation is going to be applied here. Yes, same, both way you are gonna do, and don't commit a mistake of writing R7 is equal to 6 upon 60. Most of the students do that. Yes, be careful. Whatever you are gonna do here, you have to do over there as well. So both sides operation is involved. So R7 goes up, 1 comes down. 60 goes up, 6 comes down. So this implies that here it is, or R7, and but you are gonna get R7 as R7 is equal to 60 goes up, here it is, and it is 6. R7 is equal to 60. Okay, it is also ohm. 60 ohm goes up, here it is, 60 ohm divided by 6, and finally you get 10 ohm. So therefore this is what we have got. Therefore R7 is equal to 10 ohm. Okay, so what you have got here, you have just transformed these three resistors into merely one resistor having, you can say that is resistance 10 ohm. So that's what going away. These three resistors got disappeared, and but you have got, yes, this is what you have got over here. R7 is equal to 10 ohm. So finally you got two resistors here. R6 is equal to 8 ohm, R7 is equal to 10 ohm. That's what that simplification is all about. Now it's kids' play to just make a mind that what kind of a combination they are gonna be in. So these two resistors are in series combination. Let us take a look here. That is, one end of this very resistor is being connected by means of ammeter here, is being connected to the one end of the other resistor. and the other end of this very resistor is being connected to the negative terminal of the battery, and the other end of this very resistor is being connected to the positive terminal of the battery. So it shows that it is end to end combination. Here it is the one end of this very resistor is connected to the other end of this very resistor, whereas the remaining ends of these two resistors are connected to the two different terminals of the battery, and thereby creating a situation for a series combination of R6 and R7 these two resistors are in series combination. So finally we will say here, yes, we are very much inching towards the solution of question part number 1. That is, yes, the R6, now it is quite clear from this very circle diagram that R6 and R7 are in series combination. Yes, are in series combination. Now we can find out the total resistance of the combination. So here it is A part we are gonna take on A part, total resistance. Total resistance we have taken RS. Since both are in series combination, so we have taken RS. So let total resistance is RS, and that's what our question. Total resistance is going to be, we have written here, since R6 and R7 are in series combination, therefore total resistance RS is equal to, total resistance RS is equal to the arithmetic sum of individual resistances, that is R6 plus R7, or RS is equal to R6 is equal to 8 ohm plus R7 is equal to 10 ohm, and therefore total resistance of the combination, total resistance RS is equal to 18 ohm. So that's how you can crack such kind of a you can say numerical problems which composed of complex combinations of resistances. Just do the simplification process, and very slowly and steadily you will inch towards the answer. That's how we have done over here. So the resultant resistance we have got RS is equal to 18 ohm. So that's the first part. Now we are going to take on the second part, second and final part here. And what is this? The total current. It's B part. Let total current, and it is I. That total current is equal to I, and this is what we are going to calculate, I. So it's easy to find out the total current here. And you are knowing the total resistance of the combination, it's 18 ohm. Total voltage is known to us, and it's quite easy to find out what's going to be the total current. There is a triangular technique we have already got, V, and it is I and it is R. So we want to find out I. So by using Ohm's law, yes, this is what I we are in need of. I is equal to V upon R, and the total potential difference we have already got here. V is equal to 12 volt. This is already given to us. Or I is equal to, it is 12 volt, and the resistance, total resistance calculated already 18 ohm, and it is therefore total current I is equal to 0.66 ampere, or I is equal to 0.7 ampere. So that's the total current we have got. I is equal to 0.7 ampere. So that's it here as far as this numerical problem is concerned.